I am recording this. Yay! Alright, so here's even and odd function. Super quick, I think. Alright, an even function folds in half along the vertical axis. So, folds in half like that. So you could fold it in half. Or that. Right?
Is he smiling?
That's a little smiley, yeah. Or that. Or that. Those are all even.
Why are they all even?
Because they're symmetrical along the vertical axis. Fold it. All right. Here's odd. It's symmetrical along the origin.
0, 0.
Yeah. So here's one. That one's odd. Or this one. Or that. So you do another one?
Yeah.
We could do that.
You do circles.
Circles? No, it's not a function.
Why not?
Because it wouldn't pass the vertical line test.
Can you do smiley face in the bottom left corner and the front?
No. Because it wouldn't be a function. I guess if you wanted to do the smiley face. Okay, this is going to stretch me. Here we go. So here at this. And then it's going to look like that.
Yeah. So what's the difference?
It's symmetrical along the origin. So you just flip all the numbers. We'll count it out. You'll see this. Let's just do the examples. All right. So this one, this is even, right? Because I could fold it in half along the y-axis. Be even. Okay. This one, can I fold it along the y-axis? No. And is it equal on either side of here? No, so it's neither. Neither, whatever. Okay. Example 3. This one is odd because here's my middle point, and we go positive 1 up 1, negative 1 down 1, right? So it's symmetrical around this middle point. This is odd. This one is even. You could have folded it right in half.
So you mean by folding the lax, you mean like this?
That just like that, like opening a book. Okay, so let's look at these. So we can draw this out. So we're going to draw this as an even function. So everything just needs to be equal distance from the y-axis. So I'm going to put a dot here, right? And then we'll put a dot here because this is 7, 1. So we're going to put it at negative 7, 1. And then we have 1 up here in the top corner. So we'll put this one in the top corner, and then I just connect the dots. There we go. Look at that. It's even. Right?
Right.
Okay. So let me show you what we did, because it's important. So I counted from the y-axis one away, so I went one away, right? And then I did it this way. And then from here, I did the 7 this way, so I went 7 this way, right?
Yes.
Right? And then up here, it was positive 8, so I went negative 8 to find the symmetry here. Okay? On odd, we're going to do that for both the x and the y from the origin. So, to go from this point to this point, I go positive 1, up 3. So this time I'm going to go negative 1, down 3.
I think I got it, Mr. Ray.
Good. From the origin, I will go 7, 1.
I can go 7
From the origin, I will go negative 7,
down 1.
negative 1. From the origin, we go positive 8 on the x, positive 8 on the y. From the origin, we'll go negative 8 on the x, negative 8 on the y. Then connect my dots. Points. Well, that was a little off, but you get the idea.
That's easy.
Right? Are we okay?
Yeah.
Okay, let's talk about it algebraically. Okay, what you're going to do is you're going to plug negative x in for x. And if you find that it's the same as it was before, it's even. If you find that it's the same except it's just been multiplied by negative 1, it's odd. And that sounds like a lot, but we're going to work an example, and then the light bulbs will go off, I'm quite sure. Ready? The one inside your head that you go, oh, I get it. All right, let's do this one. F of x is 5x to the 4th plus x squared minus 1. All right, so f of negative x is 5 negative x to the 4th plus negative x squared minus 1. So in the place of x, I just put negative x. Right?
Yes.
Now there's a quick way to look at this. Some of you aren't really used to this quick way, so I'm going to do it the longer way so you can see how it works. Make sense? Okay. Could you say that negative x is negative 1 times x? Can I say that?
Wait, what did you say? Negative x?
Negative x is negative 1 times x. So we're going to do 5 times negative 1 times x to the 4th plus negative 1 times x squared minus 1. Go with me so far? I just broke up negative x to negative 1 times x. No, this is negative 1 times x. Okay.
Okay, so that's just going to make the negative of 5 and negative.
No. Now, I'm going to take this 4 and I'm going to apply it to the negative 1 and to the x. So I get 5 times negative 1 to the 4th, x to the 4th, plus negative 1 squared, x squared, minus 1. What is negative 1 times negative 1? 1 times negative 1. Negative 1 times negative 1. 1. When I multiply negative 1 by itself 4 times, I just get a 1, right? And 1 times 5 is 5. So this becomes 5x to the 4th.
Oh, yeah.
When I have negative 1 times negative 1, I just get 1. So I don't have to write that down, right? So this is plus x squared. And then I just write the minus 1. What do you notice about these two right here? They're the same. If you find that you got the same answer when you plug in negative x, it's even.
Okay, but what is the faster way? You told us you're going to take the faster way.
The faster way is I say negative x to the 4th is just x to the 4th.
Okay.
That's the faster way to do it.
Okay, then x squared is x squared.
All right. Can I do number 8?
Yes.
Why, yes, you can. Thanks, guys.
Mm.
All right.
Hey,
So my original function is 2x cubed minus x. So what do I need to plug in? If I want to test for even or odd, I will always plug in negative x. So negative x of negative x equals 2 times negative x cubed minus negative x.
What does it say? Negative on top.
Are you talking about up here?
Yeah,
I'll show you. I'll show you. You'll see it. You'll go, oh, I get it. But if I try to explain it now, we won't get it. So I'm holding off. Okay? All right. So we're going to do 2 times negative 1 times x cubed. And then what's negative negative x? Positive x. Right? You with me? Okay. So then I have 2 negative 1 cubed x cubed plus x. Negative 1 times negative 1. Positive 1 times negative 1. Negative. So this is negative 2 x cubed plus x. You will notice that they are almost the same. The only difference is what? Everything's been flipped on their signs. If you notice that they're the same, except the sign's been flipped, then it must be odd. Got it? So this is odd. If you notice that they're exactly the same, then it's even. If you notice that they're the same, except the signs have been flipped, then it's odd. We good? And that's what this negative up here means. That the signs have been flipped on it. It could be muted. Are we alright? Yes? No? Okay. Take a stab at your homework and I'll come around and see if you guys have questions.